Everybody, can you hear me? Can you see my screen? So today we continue to learn chapter 3. We already learned the 4 theorems to prove two triangles are congruent. Do you still remember? Say what we have already learned. First one is SSS. That means if two triangles have 3 pairs of corresponding sides are congruent, then these two triangles are congruent, right? Then next one we learn SAS. So that means if we have 2 triangles, they have 2 pairs of sides are congruent, then the angle formed by these 2 sides are all congruent. So that means these 2 triangles are congruent. Another we learned that's ASA, that's angle side angle. That means if we have 2 pairs of corresponding angles are congruent and the sides between these 2 angles are also congruent, then these 2 triangles are congruent. Then the last one we learned that's AAS. Okay, this one, that means if we have 2 pairs of angles are congruent, then we also have 1 pair of sides are congruent, then these 2 triangles are congruent. Now we are asking a question. Is SSA also will be the theorem to guarantee 2 triangles are congruent? Okay, now let's see this example. Say here, we have these 3 triangles. Then suppose the angle C, this angle C and the angle F and angle I equals 40 degrees. Okay, this angle equals 40 degrees. Then AC equals 2.5 centimeter. This one 2.5. DE also equals 2.5 centimeter. And now let's see. We have another, let's see. We have 2 sides. One is 2.5. And another side is, say this one's 2.5. And this one is 3 centimeter. So that means what I wrote here, this one, maybe it's, let's see, this one, that's 3 centimeter. This one is 3 centimeter. This one is 3 centimeter. Now, this one, it's 2.5. This one's 2.5. 2 sides and angle, okay. This one's 2.5. This one's 2.5. But this one's 2.5. Now let's see, we can say if this angle equals 40 degree, this 40 degree, this one is 40 degree. You know, for this one, 3 centimeter, this one's 3 centimeter. This side, 2.5, this one 2.5, this 40 degree, 40 degree. Then these 2 triangles are congruent, right? Because we can use SAS to guarantee these 2 triangles are congruent. But compare this 2 with third one. This one is 40 degree. This side is 3 centimeters. But this side, HI, is not 2.5. This side is 2.5 centimeter. Then say, that means from here, we have this sides and angle. This one compare with this, say side, this side equals this side equals this side, but this angle equals this angle. You cannot guarantee these two triangles are congruent, right? Now, let's see what is the reason. Now, to do that, to understand this problem, now let's say if we give you the two sides and the angle, can you build a unique triangle from these two sides and angle? Now let's see this example. Say, in this problem, we explore why there's no set side angle congruent theorem by building a triangle with AB equals 1.8 centimeter, BC equals 1.5 centimeter, and BAC equals 40 degree. Okay, this is the steps we build this triangle. So first, draw AB equals 1.8 centimeter. Okay, so this one is easy. We draw AB. Suppose this one equals 1.8. This segment AB equals 1.8 centimeter. Okay. Then we know that BC equals 1.5 centimeter. So draw the points in the diagram that are 1.5 centimeter from B. So how to draw this? To draw this, definitely you just need to draw a circle. Let's see, you just need to use point B as the center. As the center, draw a circle B. Maybe I need just to make this one a little bit better. Now let's see. We can draw like this. This one also not good. So let me draw one more time. So we can draw like this. Oh, this is not good. Okay. Yeah, this time looks better. So then now let's see. Suppose this one, the radius of this circle that's 1.5. Okay, what I draw is 1.5 centimeter. Then the angle, you know, the angle BAC equals 40 degree. Suppose this one equals 40 degree. Suppose this angle equals 40 degree. Then, you know, suppose this point is C, this point is C prime. So then we can get this two intersection point, C and C prime. So then, say because BC equals BC prime, right? Because this is the radius of this circle, right? So then by this way, we get two triangles. One is ABC, another is ABC prime. Say these two, in these two triangles, AB, this side equals 1.8, right? And BC and BC prime, all this one equals 1.5 centimeter. This one also 1.5 centimeter because there are these two segments are all radius of this circle B, right? So BC equals BC prime equals 1.5. And this angle because C and C prime all on this line AC. So this angle equals 40 degrees. So then you compare triangle ABC and the triangle ABC prime. We have AB, they shared, equals 1.8, right? Then we have BC equals BC prime because they are radius of this circle. Then we also have angle A, all equals 40 degrees. This angle also shared. So then these two angles totally different angle, different triangles, right? You can see triangle ABC is not congruent with triangle ABC prime. They're different, right? ABC and ABC prime, they're different. So that means if you use SSA, this condition cannot guarantee these two triangles are congruent. You know, remember before when we use SSS or ASA or SAS, we can build the unique solution, unique triangles. Even there, we get another one, but that one is exactly congruent with the one we try to build, right? Only the flipped. So, but here, the two triangles, what we get here, they're totally different. So that means use SSA, you cannot guarantee the triangles you get are congruent. Now let's see number 4. Use the previous two parts to determine where C can possibly be. Say C can be here and here. So then they ask SSA valid congruent theorem? No, this one's wrong. Do we ever have case in which given the lengths of side AB and BC, AB and BC and angle BAC, there's only one possible length of the AC? Can everybody send me the answer in private chat? Say, do we ever have a case in which given the length of AB, BC, and angle—
I don't have an opinion on that.
And the angle BAC, only there's one possible length of AC? Everybody send me the private chat. By this answer this question, I can check if you really understand what we are doing here. Let's see, there's somebody send, okay, 3 persons send me the private chat. Now let me check. No. Okay. Alina. Okay, you guess that's right, but you are also not sure. Sophie, good try. Michelle, good try. So here, actually before, when in the right triangle, that's the case. We are given the length of side BC, then you only have one. Kevin got it correct. Toby, you are good try. Okay, so now let me explain why this one is the case. So remember now, if I give you this one is AB, if I give you this one, it's AB equals 1.8. Then you use B as the center, draw a circle. Suppose you use B as draw a circle. this one's circle. Then if you only get one AC, that means this line tangent this circle. So that means this line intersect with this circle only at one point. So then you can draw, okay? So then that means this angle is a right angle. This one is C. Suppose this one is 40 degrees. This one is 1.5 centimeter. This one is 1.8 centimeter. Something like this. If you try to say, do we ever have a case? Yes, we have a case. That's a right triangle, which given the length of AB and BC, then there's only one possible length of AC. So if that's one, they will have to form a right triangle. This angle will make this line AC intersect with this circle only at one point. So that means line AC tangent with the circle B. If this one's the case, definitely you can use, for right triangle, we can only use hypotenuse length. Hypotenuse, this one's hypotenuse, this one's leg, right? L means leg. We can guarantee this triangle, these two triangles, right triangles are congruent, right? So even you don't need another angle. If you know that's a right triangle, the two triangles are right triangle, then you only need two sides. One is a hypotenuse, another is one of leg. They're congruent, then these two right triangles will congruent. So then, say in this case, if AB is fixed and BC is fixed, and AC tangent with this BC, then these two triangles will congruent. So this is a case we met before. For right triangle, this one AC will has only one length. Okay. So we finished this section. Now let's go to next one. In this section, we'll learn the two special triangles. One is called isosceles triangle, another called equilateral triangle. Isosceles triangle, it's you have two sides are equal. Now you can see this example. Suppose in this example we have ABC, triangle ABC, AC equals BC equals 5. Then this triangle called isosceles triangle. Then if you know the AC equals BC, then this angle will also equal this angle. Okay, so later we'll prove that. Now let's see this example. 3.15. In the diagram, AB equals BC equals 5. And CAB, this angle that's equals 30 degrees. Then let M be the middle point of BC. Suppose M is middle point of BC. Then they ask you draw AM. So that means connect point A with this middle point M. Okay, if M is middle point, so that means this side non-CM will equals BM. Now they ask you prove triangle ACM congruent with triangle ABM. So this one, we already know AC equals AB equals 5. This is one side, right? Because we pick M is middle point of BC. So then we have CM equals BM. Then we also have AM shared by these two triangles. So then that means we can use S to prove these two triangles are congruent, right? You can just write like this. AC equals AB. Then CM equals BM. Then AM equals AM. From these three information, we can use SSS theorem to prove the triangle ACM congruent with triangle ABM, right? Now B, found angle AMB. AMB found this angle. This angle, then say these two triangles are congruent. From this, we can get angle AMB equals angle AMC, because these two angles are corresponding angles. So that means these two angles are same. Then, we also know AMB plus angle AMC equals 180 degrees, right? Because BC is a straight line. Then you combine these two conditions together, you can get angle AMB equals 90 degrees, right? You can plug this one to replace this, then you get the 2 times angle AMB equals 180 degrees. So then that means angle AMB equals 90 degrees. So we got this one equals 90 degrees. Then C, found ACB. ACB found this angle. So then you got this one is 90 degrees, and also this angle equals this angle, just based on these two triangles are congruent, right? So then we can get angle CAM equals angle BAM. This is from the congruent of these two triangles. Then this should equals 30 degrees divided by 2. This one equals 15 degrees, right? Then in right triangle AMC, we can get ACB equals 90 degrees minus 15 degrees. Then get this one equals 75 degrees. Because you already got this angle equals 15 degrees. Then this one is 90 degrees. So then we got this angle equals 75 degrees. So by this way, we proved, we finished this problem. Now, let's go to this one. 3.16. Say, prove that if this angle equals this angle, then PR equals PQ. Everybody think how to do this problem. Okay, here has a little bit tricky. Let me first show you the correct answer, correct approach to prove this problem. Now let's first draw a perpendicular line P, like PA, pass through P, perpendicular with QR, and intersect with QR at, suppose at A. Then, we draw this perpendicular line, right? So then we get two triangles, two right triangles, right? Then in these two triangles, let's see if we can prove these two triangles are congruent. See, they share the leg PA, right? Then they also have, we have this angle equals this angle, right? Now, definitely this angle also will equal this angle. Then we can use A as A, right? So first, then you know this angle will equal this angle because they give you this angle equal this angle. This one perpendicular with QR, so these two are 90 degrees. So then you got this angle equal this angle. Then in these two triangles, say A as A. So this A as A, so then these two triangles are congruent. Congruent, then PQ and PR are corresponding sides. So then they're should be equal, right? So then let's write this proof. We can write this proof is draw. First, draw perpendicular line PA intersects QR at A. Then in two triangle PAQ and PAR, we have angle QAP equals RAP. This one equals 90 degrees because what we draw is a perpendicular line. Then we also have PA equals PA. This one is shared. Then we have angle QPA equals angle RPA. Because this one, they all equals 90 degrees minus angle Q also equals 90 degrees minus angle R, because they give us angle Q equals angle R. So then these two angles are congruent. From these three conditions, we can get these two triangles are congruent. Triangle PAQ congruent with triangle PAR. The theorem we are using is A as A. Say this angle equals this angle. This side shared, then this angle equals this angle. So A as A. So then get these two triangles are congruent. Then we can get a PQ equals PR because these two sides are corresponding sides of these two congruent triangles. So then they're equal. This is the correct way to prove this. Now, let me ask you a question. You know, somebody maybe think, can we do this way? Can we just do as the first problem? Pick this point as the middle point of QR. Pick this point as the middle point of QR. Then we have QA will equals QR. QA will equals AR, right? We'll get this one equal this because we pick M as the middle point of QR. Then can we prove these two triangles are congruent? If we did not draw the perpendicular line, we just pick the middle point of QR as A. Then we will have QA equals AR, right? Then they give us this angle equals this angle. Now can we prove these two triangles are congruent? Everybody send me your private chat. If we pick the middle point of QR as A, then we connect PA. We also got these two triangles. Can we prove these two triangles are congruent? Sophie's got it correct. Who else? Alina, go to try. Kevin, go to try. You know, the correct answer for this one is no. The answer is no. If you pick the middle point, then you connect PA. You cannot prove these two triangles are congruent. You know why? Now let's check. You know, now we have QA equals AR. You have one side, right? Then PA is shared. That's another side. Now you have angle Q equals angle R. Then here, what you get is SSA. You know, we already learned in the previous section, this one is not a valid theorem. You cannot use this one to get these two triangles are congruent. Right? Say you got this side shared. This side equals this side, that's fine. Then this angle is not formed by these two sides, it's another angle. So now, actually, if you want to prove these two triangles are congruent, you try to use this, but this one is not valid theorem. We already showed you last section. If give you the two corresponding sides are congruent, and one pair of angle are congruent, you cannot guarantee these two triangles are congruent. So then that means if you pick the middle point of QR to prove this, that's wrong. That's not correct. The correct way, you need to draw a perpendicular line PA intersect with QR at A. Then you use, say, angle side. Okay, you can also use angle side angle. All these two are valid theorem to guarantee these two triangles are congruent. Okay, see this one, it's a little bit tricky. Okay, now let's go to next problem, 3.17. So in the diagram, AC equals CD and also equals BD. Then angle B equals 23 degrees. Then they ask you, what is angle A? Everybody send me answer. What is angle A? This one is very easy. Yes, Alina, you're right. Who else? Okay, this one's very easy. Say this one, AC equals CD equals DB. So Kevin or John also got it correct. Rather, you are very close. So let's see here. Then say CD equals DB. That means angle, this angle, that means this angle also equals 23 degrees because this is an isosceles triangle, right? This CD equals DB. Then AC equals CD. So that means this angle equals this angle. Now this one is an exterior angle of triangle CBD. So this angle equals sum of these two angles. So that means this angle equals 43 degrees, 46 degrees. Then AC equals CD. So that means angle A also equals 46 degrees. 46 degrees. Okay. So this one equals 46 degrees. Now let's go to 18. Say in this diagram, AXY equals XZ equals 8, and angle X equals 60 degrees. Then they ask you find the YZ. Okay, everybody try this. Say in this triangle, this is a 60 degree. Then XY equals YZ equals 8. Then they ask you find YZ. This also very easy. Let's see. Okay, good. Everybody got this correct. Ken, Sophie, Ryder, Michelle, Jerry, Kevin, all got this one right. This one equals 8. Because this one 60 degree, so then got this also 60 degree, this one also 60 degree. Because these two sides are congruent, then that means these two angles are congruent. 180 minus 60, then divided by 2. So that means all these angles equal 60 degree. Then the all sides also should say. That means YZ should equals 8. Okay. Now, very good. Now let's go to this example. In say ABCD, that's a square. ABP, this is a triangle based on build the side of this square, and also this is an equilateral triangle. Then they ask you angle PBD. Angle PBD, this angle equals what? Everybody send me answer. This one also very easy. Kevin, good try. They ask you PBO. Wait. I make this one mistake. They ask PBD, so that means connect this. Oh yeah, you're right. Okay. Michelle, correct. Now let's see. Ryder, correct. Ken, correct. Yes, good. Okay, so this angle equals 105 degree because this one's 60 degree. Then this one will be 45 degree. Then you add these two angles together, you get a 105 degree. Toby also got correct. Sophie also got correct. Very good. 105 degree. Now let's see the next problem. This one, they give you a circle. The O, it's the center of the circle. Then they also have AB parallel with CD. And the angle ABO, this angle is 24 degree. Then they also give you angle OBC equals angle OCD. Then they ask you find the angle BOC. Okay, they ask, what is this angle? Suppose this one's, okay, they ask you, what is this angle? You can suppose this angle equals X. Then this one also X, right? Then AOB will equals OC. So that means this angle also equals X. Because OBC is an isosceles triangle. Then you can find X first. Now let's see, everybody do it. See if you can get the correct answer. What is angle BOC? Okay. Now let's see. Alina got it correct. Only Alina got it correct now. Who else? say AB parallel with CD, then that means because AB parallel with CD, right? From this, we can get angle ABC plus angle BCD. This one should equals 180 degrees. So that means this angle plus this angle should equals 180. So that means we can write this one 24 plus x, then plus another x. This one should equals 180 degrees. So then that got 3x equals 156. So x equals 52. X equals 52 in triangle OBC. Then you got angle BOC will equals 180 minus 104. So then you got this one, it's 76 degrees, right? Say this angle X, that's 52 degrees, 52. So in triangle OBC, this angle will equals 180 minus 252. So that's 104. Then got a 76 degree. Okay. Now let's go to last example in this section. So in this section, we have AB equals BC equals AC. AB equals BC equals AC. So that means this little triangle, it's an equilateral triangle. Then you have AE equals EB equals BF equals FC equals DC equals AD. Then they ask you prove triangle DEF. DEF is an equilateral triangle. DEF. So that means they ask you prove DE equals EF also equals DF. How to prove this? Okay, now let's think. To prove, let's first try to prove DE equals BF. Now first, let's try to analyze this. We can say here, if we can prove triangle AED congruent with triangle BEF, then we can get the D equals EF, right? Now let's check if we can prove these two triangles are congruent. Say AE equals BE, that's fine. This side equals this side. And AD also equals BF because this side are all, this one equals this, equals this, equals this, equals this, equals this. And also they give you this one equals this, right? So then we can get this side equals this side equals this. Now, if we want to, these two triangles congruent with this one, you know, our conclusion try to get that DE equals EF. Definitely we cannot use that. So then the best probably we can use this angle and with this angle. Let's try if these two angles are congruent. To get these two angles congruent, first, now let's calculate this angle. Because this ABC, it's an equilateral triangle. So this one equals 60 degrees. Then AE equals BE. So this angle equals this angle. This angle equals this angle. This one equals this, right? So now let's calculate this angle. Angle EBF. This angle EBF equals what? Now let's say, suppose I use this one as X. This one will be 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 X. So this angle will equals 360 degree minus 60 degree, then minus x, then minus another x, right? So here, if you add these four angles together, you got a 360 degree. Then that means this angle equals 360 degree minus 60 degree, then minus this 2x. So then got this one equals 300 minus 2x degree, right? 300 degree minus 2x degree. Now let's check this angle. Angle EAD. EAD. This angle EAD this one equals, because this one also 60 degree, right? So that means this one also equals 300 degree minus 2x. So then that means in triangle ADE and triangle BEF, then we have EB equals EA, BF equals AD, then this angle EBF equals angle EAD. Then we can get this two triangle congruent, right? What do we use? That's a SAS, side, say side, angle, side. So then these two triangles are congruent. ADE congruent with triangle BEF. Then these two triangles are congruent. Then we can get side DE equals EF because they are corresponding sides, right? We can get this side equals this side. Then similarly, you can also prove triangle EAD congruent with triangle CDF with this one. Then you can get the DE equals DF. Then that means we get these three sides are all same. So that means this triangle is DEF, it's equilateral triangle. So then we get this, right? So the key point is to find these two angles are same. Here it's a little bit tricky because you cannot usually you try to find a number for that angle, but here you don't need to do that. This angle you don't know, but then you know they minus a same number. Then definitely these two angles should be equal. They minus same number from 360 degree. So then that means these two angles, they are same, even we don't know exactly how many degrees they have, right? So this is a most important skill. Now, actually, we finished this section. Now let's go to the next one. This one, we try to construct a equilateral triangle, and perpendicular bisector. You know, what you can use only it's compass and straight edge. You cannot use ruler. You cannot use protractor. You can only use compass and straight edge. Okay, now let's see how to construct an equilateral triangle with compass and straight edge. So to do this, first you draw a segment. Suppose this segment it's BC. You can use whatever letter you want, like AB does not matter. Then you use B as a center, draw a circle. You also use C as a center, but with the same, radius. Here you need to use BC if you try to build a equilateral triangle. You need to first use point B as a center and the length of BC as a radius. Draw a circle. Then you use C as a center. Also use BC as a radius. Draw another circle. It's like this. Okay. What I draw is here is not so accurate, but I show you its idea. Maybe I need to make this one a little bit better. Something like this. Still not good. Okay, one more time. Try this. Okay, something like this. Okay, then you use point C also as center. Draw another circle. But here, definitely, no, it's not good. And also, okay, now let's first draw this segment is BC, then draw a circle. Something like this. Then another circle. Because I don't, here I don't, on the screen, I cannot use compass, so it's harder for me to draw that. But then I already told you, use another point. You also can draw a circle. So then let's see. Here it's harder for me to draw like that. So then the correct way, just say first you draw a segment. Here the AB, draw a segment marked at AB. Then you use A as a center point, draw a circle, use the radius, AB as a radius, draw a circle. Then you switch the central point to B, then still use AB as a radius, draw another circle. Then you have two intersection points from these two circles, C and C prime, right? Now you use straight edge connect AC and BC. Actually, ABC, it's an equilateral triangle. You can try construct, right? You also got ABC prime. This is another equilateral triangle, okay? Now, actually, we finished this, this problem. Next one, they ask you draw a perpendicular line of BC. To do that, actually, just use what we draw here. We already draw the equilateral triangle ABC. You just connect this C and this C prime. Then the line you get C prime is a perpendicular bisector of AB. Okay, see, this is what they ask you to do. So here, actually, we finished this section. Now let's go to here. Actually, we already finished this chapter 3. In this chapter, say first we learned SSS congruous, SAS, ASA, and AAS. Later, we show you SSA is not a valid congruous to guarantee the two triangles are congruent. Okay. Now, your homework, you need to finish all the review problems and the left challenge problems. Okay. Now let's go to next chapter. This chapter, that's chapter 4. We'll learn the perimeter and area. Actually, this chapter it's very easy. You know the perimeter just it's sum of the length surrounded a closed shape. Okay, suppose you have a closed shape. You say the quadrilateral or rectangular. Then the perimeter of this quadrilateral, you just add the length of these four sides together. Then you get a perimeter, right? Then if you have a very weird shape, then that means you walk along the boundary of this shape. The distance you walked when you return to start from the starting point, then you return to this starting point. The distance you walked, that's actually it's a perimeter of this closed shape, right? For like polygon, like triangle, rectangle, pentagon, all this just you add all their sides together, then you get the perimeter of this shape. So now let's see example. Let's go to 4.3. See this one, the highlight shape A, B, C, D, E, F, G, H, I, J. Then they ask you to find the perimeter of this shape. Then they give you each grid is 1 by 1 square. Everybody, can you send me what's the perimeter of this shape? Then send me your answer. What's your answer for this? Let's see who got it. Okay, Ryder got it. Michelle got it. Correct. Okay, who else? See, this one, first you count 1, 2, 3, 4, 5, 6, 7, 8. So length of this rectangle equals 8. Then let's see why it's 1, 2, 3, 4, 5. This is 5. Then the perimeter of this rectangle that's equals 8 plus 5, then times 2, right? Give you 26. Now you think this solid dark shape, this shape, the perimeter compare with the perimeter of this rectangle, there should be same, right? Say when you can push this one to here, then push this one to here, 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 push this one to here. Then you can make this shape actually exact overlap with rectangle. Then, you know, the basic just the count, say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Correct answer is 26. Okay. You know, in a lot of math competition, they give you very weird shape. Then they ask you their parameter. Actually, that will equals a regular shape, parameter of regular shape. Okay, see this one, you can think, you can push each side of this very weird shape to the side of rectangle, then they will overlap with a rectangle. Then, so that means the parameter equals parameter of the rectangle equals 26. Okay, so now I think this section is very easy. Now let's go to next section. Next section, we will learn the area. Area, you know, this one actually, it's you use unit square 1 by 1 to fill the shape you are trying to calculate the area of that shape. Then count how many 1 by 1 square you're using. Give you that number will give you the area of that shape. See, suppose we have this rectangle. Then you use a 1 by 1 square to fill this rectangle inside of this rectangle. Suppose this rectangle, it's each side it's 2. Suppose this one it's this one is 3. Okay, now let's see. Suppose this one length is 4, width is 3. Then you use 1 by 1 square to fill this rectangle. You need how many? You need 12, right? Then you can totally fill this inside of rectangle. So that means area of this rectangle will equals 12, right? So now let's see. Suppose we have this rectangle, A, B, C, D. BC equals 5, AB equals 4. Then they said AB equals CD, right? Because this one's a rectangle. So then AB equals CD, BC equals AD. Then, and the right angles at ABCD. Then what is the area of ABCD? So this one's very easy. 4 times 5, that's 20, right? Okay. So then let's say this example, 4.6. Say the length of one side of rectangle is 4 less than 3 times adjacent side. The perimeter of the rectangle is 64. Then they ask you find the area of the rectangle. Everybody do this. See if you can get a correct answer. Let's see if somebody got this one. Or rather, good try. You need to read this problem carefully. Okay, Alina got it correct. Say, first draw a diagram. Say this one they talk about it's a rectangle, right? Now let's draw a rectangle like this. Then say one side of rectangle is 4 less than 3 times adjacent side. So now let's see. Let's suppose this side it's x, then the other side will be 3x minus 4. Right? Suppose this one is x, then this one will be 3x minus 4. Now, based on here, say perimeter of the rectangle is 64. So then you use x to represent the perimeter of this rectangle. You got the 2x, x plus x, right? This one also 3x minus 4. So 2x plus 6x minus 8. This one you got a 64. So you got a 8x equals 72. So that means x equals 9. So that means this one equals 9. Then what is 3x minus 4? That's 27 minus 4, that's 23. So like width of this rectangle is 9, that's 23. So then area, or suppose I use 8 to represent area of this rectangle, that should equals 9 times 23. That's equals 207. This one's area of rectangle. They ask you to find the area of this rectangle. To do that, you need to find the length and width. Let's suppose the shortest side or width of this rectangle is x. Then the length, that's 4 less than 3 times of adjacent side. So that means this length will equal 3x minus 4. Then you represent the perimeter based in terms of x. You got this equation, solve x, you got x equals 9. Then you got the length will equals 23. So 9 times 23, you got 24, 207. Okay, now let's try this problem, 4.8. So this one, find the area of the triangle DEF given J is on EF, and DJ that's equals 8, DJ perpendicular with EF, and EF equals 7. How to find the area of this triangle DEF? Okay, everybody do this. Say you already know this height, right? To find the area of triangle DEF, EF, that's base. You can consider this base. Height, that's 8. Then what is the area of this triangle? Now let's see who got an answer. Okay, Alina got it correct. Who else? See, to try to calculate the area of triangle DEF. Area of triangle equals base times height, then divided by 2. So base, that's 7. Height, that's 8. 7 times 8, then divided by 2. Okay, Kevin got it correct. Oh yeah, everybody now got it correct now. So 28, that's correct answer. Now let's see B. Use the previous part to come up with a way to find the area of any triangle. Does your approach work for obtuse triangles? Yes. Base times height divided by 2. That's formula good for any shape of triangle. Okay, acute triangle, right triangle, and obtuse triangle all satisfy that formula. Now let's go to 4.9. See, given this, in this right triangle, x, y, z, angle x, that's 90 degrees. Then say zxy equals xwy. That means this angle also 90 degrees. Then xy equals 8, xz equals 6, zy equals 10, because this one's a right triangle. 6 squared plus 8 squared should equals yz squared. 6 squared plus 8 squared equals 100. So that means YZ equals 10. This one equals 10. Then they ask you find XW. Okay, everybody found the XW? Everybody do this on your scratch paper. Send me your answer. This one is very easy. Let's see who got an answer. Anina, double check your answer. Sophie got it correct. Okay. Kevin got the correct. Now, Alina, you got correct. Who else? See this problem, you know, triangle XYZ, the one way to calculate the area of the triangle XYZ, you use 8 times 6 divided by 2, right? You can think XZ is base, XY is height, because this one's a right angle, 8 times 6 divided by 2. This area also we can use YZ as base, because this one we know that's 10. Height, that's what we are looking for. That's XW. This one divided by 2. So then solve this equation, get a XW that's equals 48 divided by 10. This one equals 4.8. Also, if you write fraction, that's 24 over 5. That's 44.8. So then we finished this section. Now let's go to next one. This section, this chapter is very easy. Now let's see this section. It's same base, same attitude. Attitude, that means height. So if a triangle has same base, same attitude, that means the area of these two triangles are same. Okay. Now let's see this example, 4.10. In this triangle, we have BC. BC equals 40, and CD equals 20. Then they ask you, what is the ratio of area of triangle ABC over ACD and ABC over ABD? ABD. Everybody do this. What is the ratio of area of triangle ABC over ACD? This is the first one. Second one, what is the ratio of triangle ABC over area of triangle ABD? Let's see who got an answer. Okay, Michelle got it correct. Sophie got the first correct. Anina, good try. Okay, now let's see first one. This one area, this square bracket, that means we try to find the area of triangle ABC. ABC, let's suppose BC is base. You know, triangle ABC and ACD, they have the same attitude from A, right? If you draw attitude from A to the side BD, Then you got the same attitude. This one was same for these two triangles, right? This one it's a right angle. Suppose this one it's E. AE will be the height or attitude for these two triangles. Then we can get this ratio equals, because they have the same height, then just the ratio of their base just equals BC over CD. This one equals 40 over 20. So this one equals 2. The ratio of this area of these two triangles equals 2. Because they have the same height, you just cancel out their height. You got this ratio equals 2. Then this one, ABC, you consider this triangle ABC and the triangle ABD. They also have the same attitude. So you can just use their base, the ratio of their base, BC over BD. So BC, that's 40, BD, that's 60. So you got this ratio equals 2 over 3. Okay, so this one is what we get. Now let's try problem 4.11. See, Suba and Sam have been hired to paint a triangle with base AB on the weirdly shaped wall in the diagram. They are told to choose either C or D as the third vertex of the triangle. Suba thinks using D will make the triangle looks cooler, but Sam thinks using C will result in a smaller triangle to paint. How do Suba convince Sam to choose D? Everybody try this problem. Say the one person tried to choose, Suba tried to choose C, so that means the triangle he will get, that's ABD, like this. Then the Sam wants to choose C, so the triangle he will get will like this. Now, if Suba tried to convince Sam to choose D, definitely at least the area of ABD should less or equals ABC, right? So then first, let's calculate the area of ABD and ABC, right? We don't know, they did not give us number of AB. Now let's suppose, but that's fixed. Now let's suppose this one equals A, length of AB equals A. Then we can get area of ABC equals A times 12, then divided by 2, right? Base times height. Because this one equals 6 times A. Then now let's calculate the area of ABD. You know, this shape, this triangle is obtuse triangle, right? Now, what is the height of this triangle? Everybody tell me what is, if we can still use AB as a base, then what is the attitude or what is the height of this triangle? Now let's see. Yes, Michelle, you're right. Kevin, you're right. Okay, so attitude of this triangle, that's 9. That's not 12. It's less than 12. So get this one, it's 9 times A divided by 2. You got this one equals 4.5A. So this area actually is less than area of ABC. So that's the reason by this way, Suba can convince Sam choose D as the third vertex of the triangle. By doing this way, they paint less, then choose C as the third vertex of triangle. Because area of triangle ABD is less than area of triangle ABC. Right? So now let's go to this problem. 12. AC and BD meet at X as shown. Okay. Then the given area of ABX, this one equals 24, and BCX equals 15, and CDX equals 10. Then they ask you to find the area ADX. What is the area of this part? Everybody try to do this problem. Now let's say if you have answer, you can send that to me. You still need to consider the triangle have the same height, same attitude. So first, you can consider triangle ABX and BCX. Say in triangle ABX, and triangle BCX. Then you can consider AX is base of triangle ABX, and XC is a base of triangle BCX. Then this triangle will have the same attitude, right? So by this way, you can get AX over XC, they will equals 24 over 15. Because the ratio of their area actually equals ratio of their base, because they have the same attitude, right? Then you can compare in triangle ADX and triangle DCX. These two triangles, ADX and DCX, if we still use AX as base of ADX, XC as base of DCX, then they also will have the same attitude. From vertex D, draw a vertical perpendicular line on AC. You know that one, it's same attitude for these two triangles. So then that means we can get AX over XC. This one also equals area of ADX over area of DCX. So then you can say ADX is what we are looking for. This one is what we are looking for. Area of DCX, they give us this one's 10. So you get this one, ADX over 10. Then AX over XC, that's equals 24 over 15. So then you can solve this equation, get the area of ADX, do cross multiplication, right? That's 24 times 10, then divided by 15. Now we can simplify this. This one's 2, this one 3, and 3 comes out with 24 to get 8. So you got this one equals 16. So that means area of this triangle equals 16, right? So then we got an answer for this problem, right? So see, by this way, we finished the section of this this chapter, and also we finished this chapter. This chapter is very easy. You just learn the two concepts, parameter and area. Most students, I think, you're already familiar with these two concepts. Then what do you learn to calculate the area of a triangle? Just use the base times altitude, then divide by 2. That's what we learn in this chapter. Now, your homework, you also need to finish all the review problems and the challenge problems in this chapter. Now, we still have a few minutes left. What I want to review the challenge problems homework for the previous time. When I check the homework, I see a lot of students did not get it. Or even you get the correct answer, what you're right, it's not logically. And also, it's what I don't like to see. So now let's see. Let's review this problem first. 3.41. Measure of the two angles of axis triangle are 3x plus 4 degree and x plus 17 degree. Find all possible value of x. So this one, first, you need to know isosceles triangle. That means you have two sides equal. Then this triangle will have two angles are equal, right? So then you need to assign these two numbers to the three of these two angles in this triangle. Suppose you set this angle equals 3x plus 4 degree. If you set this one, suppose you set this angle equal this angle, this side will equal this. This angle also will equal 3x plus 4, right? This one. Then this one will be x plus 17. This is one way, right? By this way, you add all these three angles together, you should get a 180 degree. Then that will be 7x plus 17 plus 8, 25 equals 180. So you got x equals 155 divided by 7, right? This is x. Another way, you can draw this triangle like this. Then you can sin this angle equals x plus 17. By this way, this angle also equals x plus 17. Then this angle will equal 3x plus 4. Then you can get the equation that will be add all these three angles together. You got the 5x plus 38 equals 180, right? So you got x equals 142 divided by 5. I think most students got this too, but then the tricky part is you have another case like this. Suppose this angle equals x plus 17, but this angle equals 3x plus 4. Then we also have this side equal this side. So that means x plus 17 equals 3x plus 4. By solve this problem, this equation got 2x equals 13. So you got x equals 13 over 2, right? So then for this problem, you got three answers, okay? So time's up. We stop here. Then finish your homework. Write carefully, okay, and also give me the details. Right. Also, I want to say use a black pen. Don't use pencil. Then take a picture. It's very light. I cannot see it clearly. Okay. So we can stop here. Bye. See you next time.